Okay, so now yesterday, if you observe, yesterday we have discussing about, what is exactly big data, what is big data, and after that we discussed about types of big data, nothing much structured, semi-structured, and unstructured as well. And we have defined and we have provided the respective examples, right? And after that, we have discussed about big data characteristics. So we are having a 5 big data characteristics. So there is nothing but volume, velocity, variety, veracity, and value. And we have defined these things, and we have provided some examples respect of these characteristics. And after that, we have started this. What is the reason to go for HDFS? That is nothing but Hadoop distributed file system. And before going for this HDFS, we discussed about what is exactly file system, and we have discussed about some limitations or some disadvantages. So what we are facing exactly from file system, we discussed as well, right? And after that, we need to, if you want to overcome these limitations, whatever the limitations we are facing from file system, so we need to go for a one more file system called as a DFS, nothing but a distributed file system. So we need to discuss this DFS as well, right? So before that, so let me summarize the some points, so in which I have discussed on yesterday, right? So big data characteristics. So the 5 characteristics that define big data are volume, velocity, variety, veracity, and value. Okay, the 5 characteristics that define big data are volume, velocity, variety, veracity, and value, right? So volume. What is volume? Yesterday which we discussed. Volume refers to the amount of data. Volume refers to the amount of data which is growing day by day. It is growing day by day. Nothing but here, volume, it is completely the data how it is generating. Not how it is generating means here how it is generating means what are the different factors or what are the different ways. So the generation. Okay, nothing but yesterday we discussed about the data which is generated by humans, machines, and their interactions on social media. All these things yesterday, this stuff we have discussed, right? And next thing is velocity. What is velocity? So what is velocity here? Nothing but velocity is the speed at which data is being generated. And we have discussed some examples as well. Okay, generated, produced, or created, anything. Okay, and variety. So variety means nothing but types of big data. How can we handle this structured data, semi-structured data, and even this unstructured data as well. Okay, handling of structured data, semi-structured data, and mostly unstructured data as well. So this comes under variety. Veracity, nothing but uncertainty or inconsistency of data. So and last one is value, nothing but deriving business from big data. Okay. So these things comes under value, right? So after that, what we have discussed. So nothing but after that we discussed about what is the reason to go for HDFS, right? What is the reason to go for HDFS? Nothing but Hadoop distributed file system, right? So before going for this HDFS, first of all, what is file system? So file system is going to store some data. File system is going to store some data. Okay, and after that we discussed some node points as well, right? So what is the first node point? Each and every operating system by default we are having one file system. So that is for Windows. What is the file system for Windows here? LTFS FAT32 on Linux ext3 or ext4. Okay, and second node point. So the format in which it is stored inside of file system is block size. So what is the format in which it is stored inside a file system here? Nothing but a block size. And also the default block size in file system is how much here? 4 KB. This 4 KB is the default block size. So that was unable to unable to change. If you want to customize this size of the block size, we're unable to do it here. That is the fixed block size. Okay. And after that, we discussed about some limitations of file system. So what is the first limitation? First one, we are unable to store huge amount of data. So we're able to store huge amount of data. Whenever if you're not able to store, definitely we are unable to process huge amount of data. And next one is data loss. Okay, next one is data loss. It can be some system failure, network failure, or power failure like this. Okay, so but each and every failure we're having a solution, right, which we discussed on yesterday. And last one is metadata, nothing but data about the data, data about the data. Okay, what is metadata here? Nothing but data about the data. Okay, so these are the limitations what you are facing from file system. Okay, these are the limitations what you are facing from file system. What are the limitations here? So first of all, we are unable to store huge amount of data, right? And next one is we're unable to process huge amount of data. So whenever if you're not able to store some amount of data in our existing file system, definitely we're unable to process as well, right? And next one is data loss. So it can be some different factors. So first one is system failure, network failure, and even some power failure as well, right? And uh, and what is the last one? Metadata, nothing but data about the data. Okay. So now if you want to overcome these limitations, right? So if you want to overcome these limitations, so we need to go for a one more file system, or a one more concept called as a DFS. One more concept called as a DFS here. So DFS, nothing but distributed file system. Distributed file system. So this file system now we need to discuss. So till now, is it fine for you? So if you are having any questions, any queries, please let us know so that we can discuss now. Is it fine, everybody? You can respond in chat. So now we need to discuss about this DFS here, nothing but a distributed file system. Let us discuss on this. Okay, so DFS, nothing but distributed file system. Distributed file system. So here, if you observe within the word, we're having a meaning. Distributed means just data is going to be distributed into n number of machines. Okay, data is going to be distributed into n number of machines. Okay, this is a world concept, so which is already exist before Hadoop came into picture or before HDFS came into picture. Okay, today we're having HDFS, but this concept is there almost 20 to 30 years back, this DFS. Okay, so here, what is DFS here? First of all, more than one machine within a network. More than one machine within a network, we are calling as distributed file system. Okay, more than one machine within a network, we are calling as an DFS, distributed file system. Distributed file system primary concept is distributing the data across the network. Okay, distributed file system primary concept is distributing the data across the network. Okay, so now let me present you some diagrams so that you're going to get some awareness. Okay, so now I have taken names for each and every system, maybe some N1, N2, N3, and even N4, right? So just I have taken some names for each and every system. Okay. So now here, this is nothing but generally what we are calling as a clustering concept. So if you are taking this all systems within a single network, right? So this concept, what we are exactly calling as a cluster. Okay. So, but here if you observe, so this is a cluster that is, we are doing as an physical. So for suppose if you take some room and within a room, so we have taken some couple of group of machines, couple or group of machines, okay, that are connected in a single network. So then nothing but what is exactly a cluster, but it is a physically nothing but in which we are configured as an end user. As a user, we are configuring the each and every system with, for suppose if you are having a new system, so what we need to configure, so nothing but we need to configure these operating systems or what are the softwares which are required and security related software, some firewall related softwares. All these things we need to configure each and every individual machine, right? So, but if nowadays if you observe, right, so you're listening this what we call cloud computing, or maybe you can hear these words AWS or Azure, okay, or GCP, Google Cloud Platform, like this. Okay, so what is the advantage of this? I mean, if you're going with these vendors, I mean, if you're going with these companies, AWS is from Amazon, Azure is from Microsoft, GCP is nothing but a Google Cloud Platform, it is from Google. Okay, so generally these things nothing but this technology we're calling as a cloud computing. So here, what is the advantage if you're going with these companies or this technology means? So here, if you observe, so if you maintain this cluster physically, okay, so it will take huge burden on us. Means, so we need to provide the complete infrastructure. So we need to buy this, I mean, either it is a laptop or desktop we need to provide, okay. And as an end user, so if you're going with a Hadoop cluster point of view, we need to configure Hadoop in each and every machine, right? And we need to allocate minimum 1 terabyte to 2 terabyte as a hard disk for storage. Let us assume if this cluster size is some 10 terabyte means each and every machine minimum hard disk size is 1 terabyte. And for a RAM point of view, if you are going with minimum 8 GB or 12 GB, need to maintain. And we need to take some group of admins. So, and we need to look after this each and every machine, whether it is working properly or not, or some unknown failures for some unknown reasons. All these things need to check it. Okay, so if you are maintaining a cluster physically, but if you are going with these platforms, okay, whether it is a AWS or Azure, so what is the advantage we need to get it? Okay, so let me discuss on this a small concept. Okay, so now if you observe, okay, I have we are doing some POCs on this Azure platform. Okay, so here if you observe this all services, I mean, this is a first of all, this is a dashboard. So in Azure point of view, and if you observe here all services, so uh, first before that all services, before all services. So here now in cloud. So first of all, we want to store some data. That is my requirement. Okay, as an end user, I want to store some data first of all. So if you want to store some data in your laptops or in your desktops, how we are doing generally? So first of all, if you want to, you need to purchase a laptop and you need to configure some either Windows or Linux operating system. After that, you need to allocate some hard disk and some RAM. So all these things you need to do, right? I mean, all these things you need to do physically. You need to do as an end user. But here, if you observe in your cloud computing or cloud platform, if you do it with some Azure. So first of all, here same way we need to configure one VMware. VMware is nothing but you can take it as a machine. First of all, we need to configure a machine with some RAM and some hard disk. All these things we need to configure. Okay, so and by default we're going to get for suppose each and every machine we're having some unique IP address is there, right? In even cloud also we're having a unique IP address. So here I already having some VMs. So let me start this VM here. We're going to get some awareness. So start this one. So it is starting. If you observe here, so starting virtual machine. Okay. See here. So it is started. Okay. So now if you observe, this is a overview of the my VM. Okay. So here we need to create some resource group. So that is the first thing. And here if you observe, this is my IP address. Okay, so whenever if you are within a network, so if you want to know whether I am accessing other IP, other IP mission, other mission or not. So generally what we're going to do, so we need to go to command prompt and we need to ping that respect to IP address, right? So same way here also within the cloud they're providing, this is my VM, for this respect to VM, this is my IP address. Okay. So, and we're going to get everything here, complete statistics on this respective VM here, 1 hour, what is happening, and each and every 6 hours, 7 days. So everything is going to display. Okay. And even while the running of this respective VM, for suppose, unfortunately, if this system is crashed, right? So you can diagnose this one. So you can diagnose and solve this respective problem. And even here we're having a one more option called as a disaster recovery. So you can recover that respective VM as well. Okay. So each and everything here, if you observe, so you can troubleshoot if you're having some any problems. So and even you can log this respect particular VM configuration. So extension, size, security. So if you observe this size, what is our size? Each and everything it will display. It's still loading. See here. So this is the amount we need to pay. Okay, so if you're going with the standard general purpose and 4 GB as a RAM, so this is the amount which we need to pay. Current generation we have taken, but I don't want this much. I don't want to pay this much of amount. Just I want to pay some uh, very less amount, maybe some 500 or 700 like that. See here, now it is 500 instead of in yours it is a 5000 like that, right? So here I need required only 500 rupees. So this is sufficient for me. So like this, I can choose this one, I can select. Okay. So now based upon this configuration, so your VM is going to be configured. So why they are giving this much of RAM? So if you observe here, 800 GB RAM is there. So why they're giving this much amount of RAM means it depends upon your data storage. Okay, within a single VM, you are storing some, uh, uh, I mean, 1 TB or some 3 TB, 4 TB of data, right? So RAM has to be, I need to take RAM with a huge size. Means I need to take minimum 32 GB RAM because I need to process the data. So when the processing is fast, so if and only if your RAM has to be support, then only your processing is going to be very, very fast. Okay. So this is one VM. So now if you want to configure as a cluster like this means you need to configure some 2 to 3 VMs and each and every VM you need to provide the respective communication internally. Okay, same this whatever thing which we are achieving in physically, same thing we are achieving in we are achieving in cloud computing, in Azure portal as well. Okay, but here we need to do each and everything. Okay, but for suppose if you are going with a new laptop, we are configuring this all these things. We need to configure OS and we need to configure n number of things. It will take minimum 1 to 2 days. But if you're going with this, either if you're going with Azure or AWS, so everything is just we need to click on the buttons. Okay, so for suppose I want to create a new VM, so just go to all the sources. So otherwise you can select here. So I need to select Ubuntu. I want to create Ubuntu operating system. See here. So like this we want to get it. For suppose Ubuntu Linux operating system, just type it as no suggestions under Linux Ubuntu. See here. It is asking version Ubuntu 16. So currently they are having at 16, 14, 18. So you can select any of these things. So I go with Ubuntu 18, right? So here you need to select this resource. 16 otherwise. All services, virtual machines, storage. This is the current virtual machines. Okay, the thing is, why we are not getting that creation of Ubuntu is because this is a trial version. Maybe they are having some limitations. That may be the reason. Okay, but generally for creating VM, it will not take some. I mean, it will take maximum 20 to 30 minutes. That's it. Okay, and after creating a VM, so which software you want to install? For suppose I want to uh, I want to install some SQL. Okay, so you can go with this SQL server. So just you need to click on this SQL server. So just you need to click on the submit buttons only. Just you need to select which version you want to install on this respective VM. These all these things it will cross check. So and finally it is going to install automatically on your VM here. So but no, I want to go with some analytics. So then you want to install these things. I want to go with machine learning. So then you can go with uh, AML, nothing but Azure machine learning platform. So each and everything, if you're going with, if you want to install some IoT related softwares, you can go with the Internet of Things. So our integrations. Now I want to integrate this. I had designed some Java applications on Azure platform. Just I want to integrate this Java application with some Android or maybe some iOS. So then you can go with these integration platforms as well. And here main thing is security. Still they are implementing so many features. So security, so we can implement security as well. So and before that, here we're having, if you observe clearly, we're having some load balancing concepts as well. Okay, so how you can maintain the storage, these all these things. And this is very important point. This is a very important feature, networking. Okay, so how you can establish a communication between two VMs in cloud computing or in cloud platform. So these things are related here. So virtual networks, load balancers, traffic. How can you maintain the traffic? Or if you want to share this public IP address, how can you do these things? And connections, network security policies, firewall protocols, gateways, these all these things you can we need to implement between two systems because they need to provide the data security as well. These all these things, whatever the configurations in which you are doing in physically for your laptop or within your physical cluster, same all the necessary conditions or necessary softwares you can implement in cloud computing platform as well. Okay, this is a best thing also. Okay, Microsoft Azure, one of the thing, and AWS as well. So is it fine, all of you? Any doubts on this? Let me know. You have got some awareness. Still, if you're having anything, let me know. Any doubts? You have got some information on this cloud computing. I mean, Azure, this you have got some minimum knowledge. So this implementing of this clustering concepts, okay, these things. So maybe I can implement this all these things on whenever I'm discussing on Spark framework. Okay, so in Spark framework, so we're going with I mean here this cluster is a physical, right? So we will create a cluster on AWS. So in that each and every machine we're having some data. How can we get the data from any of the cloud computing platforms? Let us take some example as AWS. How can you get the data from AWS? And how can you process this data by using Spark? And how can you store this data in either some MySQL databases like this? Okay, so means my point is very clear. So just I'm storing some amount of data in cloud. Okay, same amount, some amount of data I'm storing in MySQL database, which is a in our laptops or physically, I mean, okay, not in cloud. So how can we communicate this MySQL with cloud computing? I mean AWS. Between these two things, how can we provide one more framework called as a Spark or maybe some Hadoop? So how can we integrate this couple of technologies? Okay. So how we can implement this all these things? These things I will discuss on Spark framework. Okay. So find these things. So let us discuss on this one. Okay, so now here if you observe distributed file system, so let us assume that here we're having one text file. So first dot txt with 100 MB as a size, and block size is 50 MB. What is the block size here? 50 MB. How many blocks it is required? Two blocks, right? Sorry, B1 and B2. These are the two blocks required for this respective file. Because we discussed already, so what is the format in which it is going to store in file system? So if you want to store some data in file system, how it is storing internally by using a concept called as a block size, right? So here, if I take some first.txt and if you take some 100 MB as a file, okay, and we have assumed that block size 50 MB. How many blocks is required for this text file? Two blocks, right? So just I'm storing this two blocks here, some B1 and B2 for some unknown reasons, right? So if this system is down, I mean N1 system is down for some unknown reasons, right? So definitely we are losing the data, right? So that is the reason we need to maintain some duplication of blocks in some different machines within the cluster. So that is the reason I maintain some this duplication of blocks in this system in the machine N2 as well. And here let us assume like that we're having some couple of blocks B3, B4, okay, some B5, B3. So like this, just I'm making some couple of blocks. Just assume. Okay. So now here, if you observe within the system N1, so what is the blocks we're having? B1, B2, B3, B4, N2, B1, B2, B5, N3, B3, B4 and B1, and N4 we're having some B1, B5 and B3. Okay, these are the each and every system, these are the respective blocks we are having here. So this concept, what we are calling, this concept is nothing but metadata. What is the concept here? Metadata. So what is the metadata? Data about the data. Here just we are representing the, so where and all blocks are present in a multiple machines. Okay, within this system N1, these are the respective blocks. N2, these are the respective blocks. Means that is what is exactly metadata here. Okay, data is present in some different machines. Just we are representing here. It is nothing but what is exactly metadata. So let us assume this metadata also just I'm storing in this system N4. Okay, metadata I'm storing in N4. So now for some unknown reasons, if the system N4 is down, means definitely we are losing this metadata as well, right? So that is the reason even we need to maintain backup in N3 system as well. Okay, so here the important point is we need to maintain metadata backup as well. Okay, that is very important here. So this is nothing but what is exactly DFS. This is the like this it will look like. What is exactly DFS here? Okay, so and do we have limitations in DFS? Means same limitations. Whatever the limitations we are facing in our file system, same limitations here also we are facing. But here some more limitations we are having here. Okay, so for suppose splitting of data is not possible, means for suppose here we're having a file which is having some assume that maybe some 1 GB of file is there, but we're unable to split that respective file. Okay, we're unable to split that respective file. Okay, so can we store that respective file in this system? Means yes, we can store in the system as we can store. If it is 1 GB, okay, but for suppose we're having some 600 GB of file, okay, which is not splittable, so then we're unable to store in this respective system. Why? Means let us assume the system capacity is only 500 GB, then we're unable to store this 600 GB of file in 500 GB of hard disk. Okay, splitting of data is not possible in DFS if we are having a file with fixed size. That is some more limitations. Okay, and file size should be less than or equal to system computer free space, and we have to maintain information about data. I mean metadata. This thing also we need to maintain. Okay. Even in DFS also, we need to maintain this metadata backup as well, which I have discussed already. Okay, so here limitations point of view, whatever the limitations we are facing from file system, same limitations we are facing in DFS as well, but some more limitations we are facing. Okay, what are the some more limitations here? So let us represent in another diagram. Some more limitations of DFS. Yes, some more limitation means first of all, whatever the limitation we are facing in file system, same limitations we are facing in DFS as well. But here we're having some more limitations here when compared to normal file system. Okay. So what is the first one here? Splitting of data is not possible in DFS, distributed file system. File size should be less than less than or equal to system free space. Okay, we have to maintain information about data, nothing but metadata here, metadata, and also backup of metadata, backup of metadata. So here one more important point is here whatever the process in which you have in which you have discussed it till now. If you observe the previous screenshot, this whatever the file size we're having, and based upon the block size we need to split that respective file, and we need to arrange this respective blocks in a multiple machines. This process, it is not a automated, it is completely we need to do manually. It is not a automated process. Okay, and important one more important problem we are facing is here we have assumed that data is nothing but a maybe some text files or images, these things. But if you go with a complete unstructured data, we don't know exact file size as well. And if it is a streaming data, 24/7 data, so as a human always we need to check the data, and we need to split the data, and we need to split the respective file into number of blocks. So these things is a huge burden to the developer as well, very very huge burden. It is not a easy thing. And in a streaming applications we don't know exactly how much amount of data we're getting here. So many limitations are there in our DFS, distributed file system here. And major limitation is it is not a automated process. Okay, these are the limitations. Okay, so now if you want to overcome these limitations, what are the limitations we are facing in DFS as well? So we need to go for a one more file system called as a one more file system called as HDFS. One more file system called as HDFS. Nothing but Hadoop distributed file system. Okay. Now, if you want to overcome the limitations of file system and as well as a distributed file system, so we need to go for a one more file system called as a Hadoop distributed file system. Okay. So is it fine till now? So if you're having any questions, any queries, so please let us know. So now here we need to discuss about HDFS. Nothing but Hadoop distributed file system. Hadoop distributed file system here. Okay, so we need to discuss about Hadoop distributed file system. That is nothing but a HDFS. Okay, so here within this HDFS, you're having a three concepts. Major important concepts are three. Okay, very very important. We are having three concepts in HDFS. They are, so one is block size, and second one is replication factor. Okay, and third one is metadata. Okay, first one is block size, second one is replication factor, and third one is metadata here. Okay, so now if you comes under block size, first one, block size. So the default block size in Hadoop is 64 MB. Okay, the default block size in Hadoop is 64 MB. Okay, that is a default block size here, and it is not a fixed number. Even we can change this block size as well. Okay, in Hadoop 1.x version, the default block size is 64 MB, but from Hadoop 2.x version onwards, Hadoop 2.x version onwards, the default block size is 128 MB. Okay, the default blocks in Hadoop Hadoop 1.x is 64 MB, and from Hadoop 2.x version onwards, the default block size is 128 MB. And whenever this, whenever if you're implementing Hadoop in whether it is a software or software companies in software development, so if you're going with a Hadoop 1.x version, right? They are not going with default block size as a 64 MB. They are taking block size as a 128 MB. Okay. Onwards, by default, they have given the block size as a 128 MB here. Okay. So now, if you're having a file with 50 MB as a block size, sorry, 50 MB as a file, size of the file is 50 MB, right? How many blocks were required here? How many blocks? If you are going with 64 MB as a default block size, let us assume that we are having a file with 50 MB as a size, right? How many blocks are required here? Required only one block. Okay. So now you are having a F2 with the size as 90 MB. How many blocks are required? Two blocks, B1 and B2. So now we are having a file with size as 130 MB. How many blocks are required? Three blocks, B1, B2 and B3. Okay, here important note point. Important note point. Hadoop automatically. Hadoop automatically splits the given file into n number of blocks. Hadoop automatically splits the given file into n number of blocks based upon your file size, whatever the file size in which you are having. Okay, so if you observe DFS, so we need to do, whatever the process which I have discussed in DFS, we need to do completely as it is a complete manual work. As a user, we need to worry about all these things, right? But if you comes under Hadoop, if you comes under HDFS, so it is not a manual work, it is completely automated. So if you are storing some file within the HDFS file system means, so based upon the file size, Hadoop itself, it will divide that respective file into n number of blocks. This is very, very important point. Hadoop automatically splits the given file into n number of blocks. Okay. Second, replication factor. Replication factor. So first of all, here replication means duplication of blocks. Replication means duplication of blocks. So the default The default replication factor in Hadoop is 3. The default replication factor in Hadoop is 3. Okay, so that is minimum is 3 and maximum is 5. Okay, minimum is 3, maximum is 5. Note, Hadoop automatically replicates the data. Hadoop automatically replicates the data. And last one is metadata. Hadoop point of view they're calling as a namespace. Okay, Hadoop automatically maintains the metadata as well. Hadoop automatically maintains metadata as well. Okay, so these are the 3 important concepts what we're having within the HDFS. First one is block size, replication factor, and metadata. These 3 concepts, it is automated completely by Hadoop framework here. We no need to worry about these things. Okay, so first of all, if you're going with the block size means, so the default block size in Hadoop is 64 MB when comes under Hadoop 1.x version. If you're going with 2.x, default block size is 128 MB. So just I have taken some examples. So let us assume if you're having a file with size as a 50 MB and if you're going with default block size as 64 MB, how many blocks required here? Only one block. Okay, if you are going with 90 MB, 2 blocks, 130 MB, 3 blocks. Okay, based upon the block size and based upon your file size. So Hadoop automatically Hadoop automatically splits the given file into n number of blocks here. That is a first important concept what we're having within the HDFS. Now replication pattern. Here replication means duplication of blocks. So Hadoop automatically replicates the data. So minimum is 3 and maximum is 5 drop. Okay. And last one is metadata. That is nothing but a namespace. Hadoop automatically maintains metadata as well. So these are 3 important concepts. So in which we're having in our HDFS, Hadoop distributed file system. Okay. Okay. So I will explain this replication factor with with layman technology. Okay, with the layman manner, I am going to explain you this replication factor. So that now you are going to get the concept here. Let me explain you. So let us assume we're having some 3 to 4 systems. Let us assume we're having 3 systems. And these 3 systems are in cluster. These 3 systems are in cluster and each and every system it is connected here. Okay.
Okay.
You can ask the doubts after the concept. Okay, so try to mute your speaker.
Yeah.
So now this system, let us name it as N1. So now assume that we're having a text file with size as first.txt with size as 120 MB. Okay, if you are going with block size as a 64 MB, Okay, if you're going with block size 64 MB, how many blocks are required here? So nothing but 3 blocks, right? B1, B2, B3. 3 blocks are required if you're going with a default block size as a 64 MB. Sorry. 2 blocks because 64 MB, right? So because default block is 64 MB, 2 blocks were required for B1 and B2. Okay. So let us assume that this B1 I'm storing in this respective machine B1. Okay. For some unknown reasons, so this machine N1 is down. So definitely here also we are losing the data. If you observe in the, in file system, we are losing the data, right? But here we are not able to lose the data. That is the main concept of Hadoop. How much amount of data you want to store, you can store, and there is no chance of data loss. Okay, so that is the reason they implemented the concept called as a replication factor. So replication factor means here we are losing this B1 block, right? So replication means duplication of block. So duplicate this block in one more machine. So here I am duplicating this one more block, and here also one more block. So why I have made one more block here? Because the default replication factor in Hadoop is 3. So it will replicate the existing block into 2 more blocks. Total number of blocks is 3. Okay, I'm repeating one more time. Here replication factor means it will duplicate the existing block. Here already we are having one block, the block name is B1. Same block it will replicate to 2 more blocks in 2 different machines. And if you observe the total number of blocks within this cluster in B1 means, if you observe the B1 as a, if you take a consider as an B1 means total number of blocks is 3. That is nothing but what is exactly replication factor. Here minimum is 3, maximum is 512. You can replicate 512 blocks as well, but maximum in real time, if you're going with real time, so they will replicate as a default replication factor is 3 only. So maybe some 6 or 10, that's it. Beyond 10 they will not go. Okay, so is the concept is fine or still it is not clear? Let me know.
Yeah, like the data stored in B1 will be same in the replicated blocks
yes.
also, right?
Yes. Okay. Yes.
So we need for first text so B1 3 blocks and B2 3 blocks.
Yes. Each and every block it will replicate it into 3 more blocks here.
Yeah, got it. Thank you.
So I hope is it fine, all of you? Ravindra, Ramakrishna, everybody, whoever is in this session. Okay, I hope it is fine. So if you're not comfortable with this concept, let me know so that I can explain you in different manner. Okay. So this is the today's session till now what we have discussed and what is the importance of HDFS. And tomorrow we'll define the what is Hadoop framework. What is Hadoop, and we'll discuss this Hadoop installation. So Hadoop 2.x installation we'll discuss, and within the installation, so we will discuss what are the softwares we required, and how can we download it, how can we get it from Google, and how can we download all these things. Each and every step we'll discuss on tomorrow. Okay, I hope you have enjoyed this session. So tomorrow we'll meet at the same time and the same timings. Okay, thank you all.
Sir, can I have your contact number?
Why?
Because I would like, which is I stay in US and currently I'm working, so I may not attend few sessions in between, in few circumstances.
Okay, please wait. Okay, so I hope you enjoyed this session. So have a great day.